At Inquip, we produce a wide range of materials handling equipment. This loss-in-weight system is a little bit different to the ones we've normally done, where we would typically use a micro-batch feeder with a pig screw. Because of this application, and the material is a flux, which is a mix between powder and small aggregate stones, and the feed rate is so small, the client is only looking to deliver 30 kilos in about 9 hours. So the only way we could do this is through a small conveyor belt. And then with our sister company through the Meg Group, we have automation and control. They've written a control system which staggers the feed. So we literally turn the conveyor on for 3 seconds on and say 3 minutes off. But the program is written such that the client can dial in their recipe and say we want 20 kilos over 6 hours, and the system will automatically work out what the start and stop and dwell times are for feeding the material in at an accurate rate. With this particular system, the client has to preheat their known quantity of material to 200 degrees to get any moisture out of the flux. It'll then get lifted and sit back on the system. Their system will start, and then our program will hold the operation for a predetermined possibly 6 hours for the material to cool down. Once the dwell time has stopped, the piston on the system opens a slide gate, allows the material to drop out of the hopper and onto the conveyor belt, which is a time cog conveyor belt. The system will then automatically count and move the material to the edge of the belt and then provide one dose. It'll then hold on its calculated dwell time, and then it'll run a bit more and then wait 3 minutes and run a bit more. The system has got load cells, so it's generally always looking at the weight that's still remaining in the hopper, and then it's looking to see that the weight is dropping out of the hopper at the correct rate, and it will then automatically readjust its timing to make sure that the rate is dropping again. Also inside there's a couple of light sensors, so if at any time the material stops coming out, there's a part of the sequence where the material will clear to the end of the belt, reverse a tiny bit, run a vibrating motor, and then bring it back to the end position. And if it hasn't cleared, it'll then alarm. Once the hopper gets to 0, then the next time the light chamber detects that there's no product, it knows that the hopper is empty and there's only a tiny bit of product left. It then knows how far that material has to index until it gets to the end, drops the last piece in, and then runs itself for a couple of goes to make sure the whole system is completely empty.